event that we host. It's 2 days. We have a barbecue, which was yesterday, where it's just a good time for the engineers to come out and have fun and eat some food. And then we have the competition, which is what's going on now, where all the seniors display their design projects that they've been working on all year. And then tonight we have an awards ceremony where departments give out awards and we give out the winners' awards for the competition.
We definitely have the Ram pride for this.
My name's Elisa Guzman, and I'm with the Mechanical Engineering Department here at CSU, and we're out here for E-Days, of course, and it's our big competition throughout the school. What we have here is a 3-stone fire and an approved cook stove.
Our boss is technically the Japanese Aerospace Exploration Agency.
We're part of a bigger project called Good Samaritan Robot.
We're an electrical engineering senior design group, and we designed a metronome, and we use electric drum pads to input into the box that we made.
We doing the senior design project for Aero Design East regular class, and this is the plane we've spent a year building.
My name's Renata Voorhees, and I'm a mechanical engineering major, and this is our project Canine Acupuncture.
See in front of you here is the development of the 2008 Formula SAE competition car.
Hello, my name is Milo Olavenza. I'm a senior undergraduate student, and I am part of the Formula Hybrid FSAE project team here with the rest of my colleagues.
The whole thing behind this was we wanted to create a pipe organ that could also synthesize digital harmonics.
My name is Dan Strawn. I'm a mechanical engineer. I'm a senior at Colorado State, obviously. Our project is a fast pallet project. It's a test pallet that's being launched into outer space on a sounding rocket. What our project does is it goes into outer space. The whole experiment, I'm going to say, because we're part of the larger experiment. So the whole experiment is a rocket that separates into 2 spots. And a hollow capsule, what it is basically, it's a little hollow tube with an insert inside it that has a heater coil wrapped around it, and we flow xenon gas through it. Now what this does is when this heater gets really hot, it boils off electrons on the heater. They collide with the gas and make the gas really hot. It ionizes the gas. Now we also have a bias point on the outside that pulls this gas out of the hollow cathode and connects it to the ionosphere. This in turn creates a ground. And that's our part of the whole project.
My name is Stephen Goebel. I'm a senior here at CSU. As I said, we're the user interface team, so our job is to interface all the mechanical parts into a simple GUI, or graphical user interface, so that someone can control the entire robot without too much confusion or chaos. The purpose of this robot is to go into disaster scenes and basically locate victims. So to do that, we need different sensors like a video camera, thermal imager. We have a CO2 detector, and our job is to integrate all the sensors.
My name's Justin Renark, and we're an electrical engineering senior design group, and we designed a metronome. Most of us are musicians in this group, so we kind of it kind of worked for us doing a metronome that way. And we can do tap tempos and hit counters and rhythm playback with it.
The car will go 0 to 60 in about 4 seconds.
I have driven it.
It's got a 600cc Yamaha R6 inline 4-cylinder engine, 6-speed transmission.
This car is a blast.
It's about as fast as a crotch rocket in acceleration.
It's unlike anything else I've ever driven.
The way we've got it geared, it tops out about 85 miles an hour.
It's quick, it's responsive, it's like riding a crotch rocket on 4 wheels.
It'll pull 1.5 Gs in lateral acceleration, so cornering. It'll pull almost a G in just accelerating from the stop. And in braking, it'll pull about a G as well.
This is the 2007 Ram Racing competition vehicle.
There's actually a skull inside of this, and for acupuncture that's important because you palpate the mannequin all over, and so you can feel the underlying contours. Several reasons. If undergoing cancer treatment, they are put under a lot of stress, and a lot of them have bad joints, and it helps their joints.
We're flying it at the SAE Aero Design competition in Fort Worth, Texas. This year's restrictions included a 1,000 square inch planform area, specified engine, and specified takeoff and landing distance.
Half of the world right now is cooking with these types of fires. As you can see, the smoke coming out. This represents a typical hut in a Central American or South American home. And we decided to leave it clear so that people could see the smoke and what was going on in there. But the reality is that people are dying. Every 20 seconds, one person dies because of the conditions in this hut. And so what we decided, our team, was that something had to be done about this. And we teamed up with Helps International, and we have been working for the past year on improving a cook stove and making a cook stove that could fit into a home and that wouldn't do any pollution like this does and harm so many people. The stove itself consumes only 30% as much wood as an open fire, so there's 70% fuel reductions. And like I said, the smoke, as you can see, there isn't any black smoke coming up top anymore. It's completely, safe for being inside of a home. It's really been something to be able to use our engineering degrees to better someone's life has been more than words can express, the feeling that it's created and the opportunities that it's given us.
We've been given the task of utilizing the 1998 chassis and implementing the components, electrical components from the 1990 solar car. We've got a 250cc engine with a 20 horsepower engine or 20 horsepower motor in the back, powered by 2 sets of 53 volts of nickel metal hydride batteries with the option to run lead acid batteries as well.
My name is Dallin Kuzmich. I am majoring in violent performance and electrical engineering. We've augmented real pipes with speakers that output sinusoids at various amplitudes.
Little 12-bar blues, Miles Davis, all blues.
Part of the reasoning behind this is that pipe organs are very complex and very expensive instruments. And so by able to substitute some of the pipes with digital ranks and speakers, it cuts down a lot on the cost, and it gives us an avenue to do a lot of signal processing work. And understand, what makes music music.